think we might as well crack on then. Thank you for joining today. This is going to be about securing AWS estates at scale, ideally, against what we see in the real world in terms of breaches and real attack vectors. So roughly what I'm going to be covering, some of the common misconceptions, things that I often run into that I hear clients asking about and questioning with their security programs. Some of the real world breach data we've got from incidents that have happened that we can learn something from. A little bit about what we see, and by we I mean me and my fellow consultants inside organizations, and how we typically effect a breach if we're on a red team or a penetration test, what that really looks like. And then based on all of that, what I would say are the real key security controls, based on my experiences on what would have stopped us or what would have stopped the attacks that our incident response team spend their time on. So before we get started, who am I? So I'm a principal consultant with Secure. As you can tell, I'm not from around here, by the accent probably alone. These days I'm out of Copenhagen in Denmark. We're spread out across most of Europe with a New York office for consultancy too. Big consulting arm, but also security products and services for sort of small and medium enterprises and some managed detection and response, that sort of thing as well. When I'm not doing that, I'm an AWS community builder. I see we've got at least one other in the room, so hello down there. Yeah, I tend to run around doing these sorts of talks at quite a few places. Forward CloudSec, if you're not already familiar with it, is definitely one to keep on your agenda. They often have some amazing talks, and I've been lucky enough to be there myself a couple of years now. So, common misconceptions. When people start thinking about security, often, especially in larger organizations, people are thinking about individual pieces of the puzzle because things are so broken up and so spread out across different teams. If you're lucky, you might have someone thinking a bit above that. But often, even when we talk about it at a higher level, when people say AWS security, they think about a box that looks a little bit like this. You've got an AWS organization. Within that, you've got a bunch of different workloads, hopefully spread out between some accounts, but maybe not. And there's probably some CI/CD, a code repo or two somewhere lying around. And that is the model that people think about. We do a lot of threat modeling in on this particular workload. Okay, we've got a Kubernetes cluster, we've got some S3 buckets. What are the threats against that? If the organization is thinking a bit further ahead than that, they might also be thinking about what happens if an attacker gets into their CI/CD pipelines and what can happen from there. But actually, in the, in the real world, for those of you who do a lot of cloud work professionally, how many of you only have a single cloud provider in your organization? I'm seeing, oh, wow, okay, we've got a couple of hands. I'm surprised. Usually when I ask that question, you'll often have someone say, oh, we're an AWS house, or we only work in Azure. And then there'll be an engineer stick their hand up at the back of the room and say, oh, well, actually, there's this other box in the corner. In our case, we do an awful lot of AWS internally for our products, but we've also got one thing that could only run on Azure for various reasons. And there's some Google Cloud in the corner the IR team use, and all of these things. And when you then plug that into your source code being on GitHub, and all of that plugged into a bunch of Slack bots, and your documents in Office 365 or in Google Workspaces or what have you, the attack surface of a modern organization is enormous. And even if you're at a point now where you don't have all the on-premises stuff to worry about, we used to have Active Directory and all these big file servers and all this sort of thing, even if all you've got are workstations now that are physical devices people are managing, that's still a huge attack surface, and pretty much no one's got the team or the funds to really do a good job securing that. So you have to be really quite careful as to where you pick to invest your time. And I'd argue actually in many cases, focusing on AWS and the components you've got deployed there is important, but I think doing that often misses a lot of the other points. So we'll get onto some of that in a second. Partly because attackers don't really target the cloud specifically in a lot of cases. Many do, but it's not the only starting point. So it's still really, really common to see attackers phishing an end user, maybe pivoting around a bit till they get onto an engineer's laptop if they started out in accounting or something, but launching that initial phishing attack to get a foothold and then pivoting up into the cloud from there. We've seen quite a few cases where people have stolen something out of an S3 bucket that's then allowed them to pivot onto other cloud resources. Sometimes the S3 bucket itself might be bad enough, but those kinds of exposed resources are often an initial starting point for further attacks into an organization. And sometimes that even goes as far as stealing things out of the cloud that then allow you to pivot back on premises and start breaching internal stuff someone's got stashed in a data center somewhere, right? So attackers tend to move around a lot more than people often think about, if they have to. Once you get past the point of it's just an open S3 bucket that someone's stolen some data out of, this becomes more and more true. There's also a few myths, though, that I see people throwing around a fair bit. By and large, every attacker looks for the path of least resistance. They want to put in the minimum quantity of effort that they have to achieve either a goal or an opportunistic sort of smash and grab of someone's data out of an S3 bucket. All the basics help stop all of the Russian advanced persistent threat stuff as well. One of the best examples there was all of the SolarWinds stuff a couple of years back was caught because an employee noticed they got a prompt for a new MFA device that wasn't supposed to be there. So then the SOC took a look and went, well, hang on, this doesn't look quite right. And that unraveled a multi-year-long Russian APT campaign targeting the US government, purely because someone was paying attention to their MFA prompts, right? So getting all that right will also help stop the high-end stuff too. Pretty much everyone gets hit as a result of getting the basics wrong. Public S3 buckets is no surprise, but AWS accounts that get left lying around and forgotten about, or legacy workloads that haven't been onboarded into the modern monitoring stuff people have, or all of these kinds of things is a common culprit. People pushing access keys to GitHub, still a problem, unfortunately. And I'm going to say admin rights granted to stupid things. I guess what I really mean by that is people giving IAM policies that have *:* or similar to entities that really didn't need them because they had a deadline and we needed to get this working, and we'll come back and clean it up later. Spoiler alert, no one ever does. As much as I love a lot of the stuff AWS does in terms of the advanced security features they're pushing, Nitro enclaves, a lot of the newer security services that they're building out, pretty much no one ever gets breached because they weren't using one of those. Corey's comment at the end of the last one about how AWS Security Hub and turning it on is something you should do even just to keep the auditors happy, or for when there's a breach and you need to say, look, we did some due diligence. A lot of the things that I hear people talking about in the security community, they are more defenses against auditors and against bad news in the press than they are about actually doing real security and preventing breaches. Another classic example, encryption at rest. Are you using custom KMS keys or do you just have the default turned on? In reality, I don't think I've ever seen a single breach or a single scenario we've played out in a pen test or red team that custom KMS keys would have stopped, where there wouldn't have been a better option for cheaper to have prevented the same attack path. It tends to be a good thing to do in highly regulated environments because it keeps people happy. It's not what stops you getting breached. Equally, cloud 0 days are a thing. I'll get onto that in a bit more detail later, but as far as I'm aware, there's not a single breach yet based on that. And insider threat at AWS. Oh, what happens if an AWS engineer goes rogue and starts stealing our data? No evidence to suggest that's ever happened at any cloud provider, and probably not something to be worried about compared to all the other things that you could get breached by. So, real-world breach scenarios. I'm going to be using a data set that someone pulled together a little while back to talk about how people are getting breached, really, based on what's being publicly talked about. But this is an inherently flawed data set. Not all breaches get spotted. A lot of organizations don't like talking about it. AWS themselves hate talking about anyone getting breached, and security incident was a banned term up until about 18 months back, I think. It also tends to focus on low-hanging fruit, the easy things to spot, because people's security monitoring at the moment generally isn't that advanced in the cloud, and so therefore it's only the basic stuff that tends to get spotted with any regularity. Cloud 0 days. The idea that people are finding novel vulnerabilities in the fabric of AWS or Azure and using that to do breaches, they are there. They're starting to get found more and more. They're interesting and they're fun from a security perspective, but in reality, the cloud vulnerability database is tracking over 120 of these that have been reported over the years, of which one we've heard of being exploited in the wild, and I'm not aware of that being tied to any actual breaches that then went anywhere or hit the news. So mostly irrelevant still, but I do expect that to change. You might have seen Orca in the sponsor stands out there. They've got a team of people looking at this. Lightspin, Wiz is sort of the 800-pound gorilla in this space. They've got a team of about 15 or so researchers who churn out a new 0 day a month practically. And if you want to get more of an idea of where this is going, the full CloudSec 2022 keynote is a good watch. But realistically for now, this is not a concern I'd bother investing time in. On the other hand, open S3 buckets. I think we've all heard this story over and over, but it does still continue to be one of the biggest sources of breaches. It's a really easy one to fix now. There's a nice checkbox you can tick that says, block all S3 public access in my account, please. AWS have done a lot lately to try and improve this situation, but in reality, I'm seeing a lot of organizations not following through with this, and so they've still got stuff exposed, and breaches are still going to continue to happen. So if there's one place you go home and double check for, this is the thing to look at, unfortunately. So the data set I'm going to work with for the rest of this was pulled together by Rami McCarthy, and this is out of one of the decks that he produced to talk about this. What we can see here is where it says abuse of valid and abuse of stolen. He's talking about credentials, and so credential theft and abuse accounts for about 2/3 of the cloud attacks that we've seen happen in the public, right? So that's either disgruntled employees whose access should have been taken away when they were fired, but it wasn't, or it's someone's pushed some keys to GitHub and they've been found, or these kinds of things. So identity and access management remains, at least for me, the one key thing that is critical in terms of actually securing your estate, but also quite hard to get right. The complexity of AWS IAM obviously doesn't help there. Other interesting bits from here, though. S3 global write. What that's referring to is cases where an attacker's been able to write into an S3 bucket, often containing JavaScript that's serving a website. And what that usually then leads to is credit card stealers running client-side on a website that's taking payments. And that malicious code that's been inserted into the S3 bucket is used to steal and exfiltrate credit card information that way, right? So we've seen a few of those over the years. The idea that you could accidentally set your S3 bucket up to be sufficiently public that anyone can write to it was a fairly novel concept for me, but it turns out it happens with more regularity than you'd like. And then in terms of what we see, that credential theft that I was talking about previously, or the abuse of valid credentials, is definitely something that we find ourselves exploiting all the time, and that our incident response team even keep responding to. Credentials in public repositories, I've mentioned already, but it keeps happening. Theft of credentials via exploits in an application is a relatively common one. That was what hit Capital One back in the day, and why Instance Metadata Service version 2 for EC2 is now a thing. But at the end of the day, a lot of it still boils down to phishing, and that's not going away anytime soon. So as an example attack path that we pulled off probably about 6 months ago with one client, we were given a developer's laptop and told, all right, see what you can do from here. And we went digging around in the GitHub repositories that we had access to as a standard developer, and quite quickly found some access keys. That then led to us poking around, finding out what we had access to and what we could do with those keys. And they had quite a few permissions for some quite interesting services. But most relevant, after poking around a bit, turns out they were using SSM to manage all of their EC2 instances, which meant you then had Systems Manager, Session Manager, that you can then use to spawn shells as an administrator on all the EC2 instances they had. So the next thing you know, we'd use that to spawn a root shell on an EC2 instance that was running their primary MySQL server with all the data on, and out that data went. I really like Session Manager as a way of managing EC2 instances, but you've got to get the IAM permissions for it right and make sure that you're not granting excessive access to stuff that doesn't need it, because otherwise it makes an attacker's job really easy once they do get hold of that access. And a note on phishing in general. We're seeing more and more people adopt Okta, one login, auth 0, things like that over old school Active Directory, which is great. I love it. But it means you've got a single point of access to everything. And we've seen Okta get breached, and thankfully nothing came of that. But it does wake people up to the idea that there's actually a fairly significant supply chain risk here too. If they get breached, everyone's going to have a really bad day. But they also have some quite interesting security properties in that you usually need multi-factor authentication and sometimes sort of like the agent running on the device to say that, yes, this is a trusted device, all of these kinds of things. In many cases, though, once the user's authenticated, the session token that says they're authenticated can actually be picked up and used from anywhere. And so we had one case where we got a initial foothold on a developer's laptop, stole the session token for one of the ones that's up there, I won't say which, and picked that up, took it off to a DigitalOcean box running in the cloud somewhere, and started getting into their GitHub and their emails and all kinds of other things from this DigitalOcean box, because the single sign-on platform wasn't checking that this session token that we got was being used from where it was originally created. So once we'd stolen that, game over. Equally, a lot of the really shiny, fancy tools that developers like using for building all their code has upsides and downsides from a security perspective. The one that we've been playing around with most lately is tied into Terraform, either Terraform Enterprise, Terraform Cloud, or Atlantis, which is the open source equivalent. So we've had a lot of fun with them. And it's allowed us to bypass a lot of the controls that people put on production code deployments. So in this particular case, let's say we fished a developer, or we started off with a foothold on a developer's laptop. You get access to some interesting infrastructure as code repositories because they're a developer, they work with these things, right? And then, in this case, the repositories were hooked up to Terraform Cloud. And the way that that works is you open a merge request, and Terraform Cloud looks at the Terraform that's in the merge request, runs a Terraform plan, and returns the changes that this will make to the environment, and posts it in a comment on the merge request, so that other developers can look at it and go, oh yeah, that looks reasonable, all right, fine, we'll sign it off. But in order to do that, it has to compile and run the Terraform, and you can embed arbitrary code in Terraform files in a couple of different ways. And so purely by opening a pull request without any kind of approval or anything, we were then able to get code executing inside Terraform Cloud, which then allowed us to steal the credentials out of Terraform Cloud, and ended up with a conversation on Slack with me saying, hey, what's this random AWS account ID? Oh, that's our main production system. If you could stop going any further now, that would be great. Just pause there. So yeah, we ended up with administrative rights over their production systems merely by opening a merge request on one of their GitHub repos. Not great. So there's a few things that we can do to try and stop some of this, right? Quite a few actually, but I'm going to highlight some really key ones. I would say identity and access management is both the critical security control in the cloud, and also the one that, as a industry, we probably have the worst grip on of all the different things, right? People constantly get this stuff wrong, and it is hard, and it's all very complicated, and that's not great. But some initial starting points, everyone always says it, but please, for the love of God, turn multi-factor authentication on everywhere, force people to use it. That has stopped more breaches than anyone can count at this point. So definitely go do that. Principle of, I'm going to say not very much privilege rather than least privilege, because everyone chases this idea that we can narrow the permissions exactly down to exactly what they need to be for every single resource. And that works when you've got 2 AWS accounts. It doesn't work when you've got 2,000. You just can't do that to that degree. Across everything, it takes too much developer time, and they've got better things to be doing. So what I generally recommend here is a combination of having some standard permission sets that you give out to things that are reasonably well tightened down. Let's say we know that EC2 instances are going to need access to S3 buckets. Maybe we don't par down to the exact S3 buckets they need, but we don't give them the rights to start playing around with SQS or other AWS services, right? And you can kind of compose access based on sets of those policies. But also, the closer you get to having everything isolated in their own AWS accounts, the less the IAM permissions of the individual resources matter, right? Because if you've got every workload boxed up in its own AWS account, and you've got your dev separate from production and all of these other things, then if one particular workload gets breached and the attacker ends up with a lot of control over that one account, they've still only got a small portion of what matters in the grand scheme of things, and therefore the IAM permissions in each little bit matter less to your overall security model. I'm on a bit of a crusade about IAM users. They are fundamentally the worst idea that we still have in AWS from a security perspective, as far as I'm concerned. People generate access keys for them. The access keys live forever. They eventually get chucked into some GitHub repo somewhere, or they're left lying around on a developer's laptop somewhere silly. And the number of breaches that I've ended up helping our IR team respond to that have had that as the root cause is more than I can count at this stage. So there are cases where you still need them. If you've got an on-premises system that is connecting to AWS, you might not have a better option. But now that we're doing things like OIDC authentication for IAM roles through GitHub, all that sort of stuff. We need these less and less, so get rid of them. As part of that, equally, use IAM roles wherever possible, because then AWS manages the key rotation and stuff for you on a regular basis. That's all great. And then as a last thing on this list that you might eventually get to, but I wouldn't worry too much about, automating credential management and rotation for things where you can't have AWS do it for you. And that's things like SSH keys, API tokens for third-party services you speak to, all this sort of stuff. Some of the more fancy secrets management platforms like HashiCorp or Vault have some features built in to help with that. So if you have those already, it's worth a look. I wouldn't invest too much time in that, though, as a starting point. Avoiding people in production. The harder it is for a developer to go start poking around in production, the less likely there is to be a breach that results from a compromised developer and an attacker then poking around in production. So part of that is if you get to the point where your observability is good enough and your CI/CD systems are fast enough that developers can work out what's gone wrong and then push an emergency fix through the standard channels, then there's a lot less of a need for them to be able to jump in and poke around, right? So that's a goal worth chasing for sure. Quite a few of our clients are then building out these production access control systems where you have to request a way in and someone approves it, and it gives you a special box that lives for the duration of the incident, and you log everything that someone does on that box and ship that off to whoever's doing the security monitoring. And that way you know every time a developer's gone into production, you know what they've done, you know why they've done it, it's tied back to your incident management systems, and it keeps a much closer eye on what people are doing when they're anywhere near your customer data. Alongside all of the bits I mentioned about IAM being a problem, secrets management is the other big one. They are pretty well tied together. For any time we've got systems communicating with each other, you've got API keys lying around, all this sort of stuff, it's worth having a standard process in your organization for modeling where the secret needs to get stored, how does it get rotated, how are we monitoring for where it's being used and if it's being used maliciously. These should be part of the standard process for threat modeling any sort of application or platform that's being built. Specifically for AWS, use the AWS services to do heavy lifting where you can for you. So secrets manager is great, gets expensive at scale, which is why I see people using systems manager parameter store instead. HashiCorp Vault is amazing if you've got the bandwidth to have some people look after it. It's pretty maintenance heavy and you've got to get it right. But that plus IAM authentication is pretty powerful for managing tokens for third-party systems and stuff. Common places I find secrets if I'm poking around looking for them to do bad things. EC2 user data buried in scripts there, that's super common. CloudFormation templates occasionally. Hard-coded creds in an application source code repository is not uncommon. And disappointingly, yeah, people put all kinds of things in S3 buckets. I've had root SSH private keys and all kinds of stuff over the years. Just conscious of time, so moving reasonably fast through the rest of this. I mentioned earlier on about how IAM becomes less important if everything's boxed into its own accounts. The broader principle of limiting the blast radius of any given breach is quite an important one. And so separate AWS accounts for everything is great wherever you can. VPC peering is something I always recommend avoiding where you can, because again, you're joining things together. I know of at least a few vendors who recommend peering their VPCs with yours so that your systems can have access to the thing you bought from them. And that always terrifies me, because then if they have a breach, you essentially extend the breach into your own environments, not what you want to do. Keeping dev, QA, and prod in separate accounts is also extremely important. And if I had to choose between keeping workloads in different accounts or keeping my test stuff away from my production stuff, keeping dev and prod separate is definitely the more important of those two. And anything you can do to minimize the access any shared services like CI/CD systems or observability and things have between the accounts, or more importantly, from the workload accounts back to the shared services. Anything you can do to minimize that is going to be a security win for you for sure. Lastly then, security in the cloud is hard. There's a lot of it. There's a lot of stuff to think about. Realistically, no one or two people are ever going to be able to cram all this into their head. So really the way to do it, in my opinion, is to devolve as much of the security as you can down into the engineering teams, help them get it right, and then you don't need as big of a cloud security team, right? Because at the end of the day, at the moment, with the skills shortage, good cloud security people are scarce and expensive. Tooling's expensive. The more you can have the engineers do or equip them to do for themselves, the better a time everyone's going to have. So, to wrap up, security of the cloud extends to a lot of external factors, some of which people think about, some of which people don't. Identity and access management, both in terms of how you authenticate to and manage the cloud, but also AWS IAM and the authentication and permissions inside the cloud are both extremely important and a place worth focusing, but don't chase principal of least privilege too heavily because you've got better things to do with your time, frankly. Secrets management's a big one, segregating your environments out, making sure that your CI/CD systems are hardened and that you've not got Jenkins sitting in a corner with all kinds of old vulnerabilities present. All very good things to focus on. And if you're operating in large environments, the only way that you can really do this effectively is a load of automation and tools and things, and empowering the engineers themselves to do the bulk of it for you, at which point security becomes a expert organization providing advice and sort of critical support where it really needs to. Yeah, it's really the only way I've ever seen it done successfully, I think. And with that, thank you for listening. I think we've got lunch now, I want to say. Fantastic. So I'll hang around for questions if anyone's got any, but otherwise I won't stand between people and their food.